Alrighty, so in this section we're going to talk about comparing inductive and deductive reasoning. Who knew there were two different ways to think about stuff? I don't know. I guess there are. But it's important that for inductive and deductive reasoning that we remember they're both important. They just have their place. So let's see how it works. So first we're going to compare them in contrast, and then we're going to look at some examples of both types of reasoning. And then what we're going to do is we're going to recognize from some examples that we have whether or not they're inductive or deductive. All right, let's see what we got. Induction. It says induction is about observing and speculating. Okay, so we first look at a whole bunch of things, and then we gather the empirical evidence together, and then we use our intuition. And we basically, induction is about recognizing patterns, right? It's about recognition. And it's about noticing things. It's about that observation phase of thinking, right? It's not considered a proof in the conclusive sense, okay? It's not conclusive proof. It can provide justification, but it's not considered a proof, as we know. Deduction. So deduction uses previously established facts, and then we draw conclusions using logic, okay? So we don't just look at a pattern and then assume the pattern will continue. We have to show the reasons why the pattern must continue. And that's the difference. Deduction gets down to not just observing what's happening, but showing why that thing always has to happen. It's irrefutable truth, okay, if it's used correctly. And it has to be considered concrete proof of conjecture. So in science, you know that you run an experiment so many times and then they start to believe it's true and they eventually call it a theory instead of a hypothesis to give it credit. But in math, we don't accept things that are just sort of theoretical. We have to prove that they're true. They're very different processes, but both are important in mathematics, and we often have to use the two of these things together to make what we call significant contributions to math, or to make some progress. We have to use our induction to observe patterns, and then try and deduce why those patterns are actually true. Okay, so using both types of reasoning, let's make and prove a conjecture about the product of any even integer and any odd integer. So here's the process from the beginning. We don't have a conjecture, we don't have anything. All we know is we want to look at even and odd integers and what happens when you multiply them. So a good place to start is what we call specializing. Pick some examples and go for it. So this is inductive. Okay, we're going to gather some evidence first. So we'll take like 3 times 4 and we'll get a 12. Okay, let's pick another even and odd integers. How about negative 5 times 10, and that gives me negative 50. Okay, let's go with 4 examples. So we'll say 7 times 18. Let's see, that's 70 and 56 is 126. Okay, and how about negative 1 times negative 12, and that gives me a positive 12. Okay, so what do we notice about all the answers that we get? Well, the only pattern that I can recognize, maybe your induction is better than mine, but the only pattern I can recognize is that these are all even numbers. So the only conjecture I can make is that the product of any even integer and any odd integer is even. So that's my conjecture. So all of that is based on my induction. Now what I have to do is I have to try to prove that. Okay, so first I have to represent an even integer as generally as I can and an odd integer. So there could be any two numbers. So let's take x and y are just any integers. Okay, so we're going to let x and y, usually write that math, let x and y be any integers. So then 2x is going to be even, and 2 times y plus 1 will have to be odd, and we've already established why we use those little tricks, okay? So once we've gotten that far, then I want to look at the product. So I want 2x multiplied by 2y plus 1, and we're going to see what happens. So let's expand that out. 2x times 2y is 4xy, and 2x times 1 is 2x. Now, what we're trying to show at this point is that it turns out to be even. And remember, all we have to do to show that it's even is that it has to be divisible by 2, or it has to have a factor of 2. And I can see right away that this big mess has a common factor of 2. So I pop that common factor of 2 out of there. I'm not looking for the greatest common factor, just a factor of 2. So I'm going to take that out, and what I see is that I get something that's got a factor of 2. So therefore, 2x times 2y plus 1 is divisible, or let's not even say that, let's just say it is even. And that's how we've showed it's even. So inductive and deductive reasoning is an entire process. We use induction to get our ideas. Then we formulate a conjecture based on those ideas. Then we have to use deduction to deduce why it's true, or to prove that it's true. Okay? Alrighty. So let's identify which of these is inductive and which is deductive. Jericho lives in Toronto. He has only ever seen cars with 4 wheels, and therefore assumes that all cars have 4 wheels. That's inductive. He hasn't proven it. In fact, there are cars with 3 wheels, aren't there? In Europe, often see, in Asia. But that's inductive because he looked at the evidence and formulated a conjecture. Susan uses an algebraic derivation to show this, that the sum of the integers or the numbers from 1 to n equals this. That's deductive because she proved it using an algebraic derivation. Okay, so that's deductive reasoning. Jimmy buys an old car with a broken gas gauge. The first 7 times he fills his tank, it takes 30 liters of gas. So Jimmy concludes his car has a 30-liter tank. I think that's inductive. There's nothing to guarantee the next time it won't take 35 liters. Okay, so that's all the stuff. Both are important. Inductive is based on empirical evidence. Deductive is based on logic. And it is usually through inductive reasoning that we form conjectures and we prove them using deductive.